Thank you so much for joining us for this webinar on harnessing the cloud for your big data strategy. My name is Lisa Glenn, your host and presenter for today's session. Joining me as the big data expert from Impetus Labs is Gaurav Nigam. Now, Gaurav has contributed significantly to our big data projects and has established thought leadership on this subject. In this 45-minute session, we're going to discuss how adding cloud to your big data strategy can help you create faster, smarter, and better big data solutions. So let's go ahead and take a look at what today's session has in store for us. Enterprises globally are integrating big data and cloud computing to address numerous business challenges. Cloud computing enables the ISVs to store, manage, share, and analyze their big data in an affordable and easy-to-use manner. In our session today, we're going to highlight how cloud can be leveraged to solve the major big data challenges and the various strategies of moving your big data solutions to cloud from the traditional data centers. There will be a special focus on addressing security, scalability, maintenance, and performance challenges. We will also discuss a real-life experience of leveraging cloud in the big data strategy. So let's ask ourselves, is big data a problem or is it an opportunity? Well, we think big data is a big opportunity. Leading companies like Google, Yahoo, and Walmart exploited the big data and new analytics platform for competitive advantages. These companies were really at the forefront of developing new categories of big data and analytics-driven business applications. With their expertise in big data, they address their critical business problems in a cost-effective manner. However, there are certain issues in big data that needs to be effectively addressed if you want to explore the potential of your big data. Now, on your screen, you can see some of these issues that kind of put a chink in the big data armor. They include, but are not limited to, the rapidly increasing size of data, the ability to access multiple databases, data centers in multiple geographical locations, and so on. There is a need of an effective solution, especially as the big data problems are progressive in nature. Let me share with you some results of a survey conducted by the IDC's Digital Universe study. Now, it predicts that between 2009 and 2020, the digital data will grow 44-fold to 35 zettabytes per year. Now, this enormous data creates new opportunities for data analytics in areas such as human genomics, healthcare, oil and gas, search, surveillance, finance, etc. I now would like to ask you, our audience, a question. What, according to you, is the most critical big data challenge? Now, you can see that there's a poll question running on your screen over to the right, and your options are these. A, storing this large data. B, gaining meaningful and actionable insights from this data. C, migration to cloud. And D, data security. You have a total now of 30 seconds to respond to this poll question, so please go ahead and do so now. It looks like we have the results, and it looks like 46% of our audience indicates that applying analytics and gaining meaningful insights from this big data is their most critical problem. I'd like to now ask our expert speaker, Gaurav Nigam, our big data expert, to comment on the poll results. Gaurav, what do you think?
Hi all, and thank you all for joining us today. I agree with you on the poll result, and I believe that data is a critical problem, and analyzing the big data is again a problem. Organizations do face challenge in analyzing their data. We'll discuss more about the big data tools to analyze your data, as well as how the solution implementation strategies in the later part of this webinar.
Great, thanks so much, Gaurav. Now, using analytics on the big data facilitates correct business decisions and developing the right business strategies. Now, the big question here is, will adding cloud to your big data strategy enable faster analytics and spell significant cost savings for you? And the answer is yes, it will. Cloud computing does help your organization to store, manage, share, and analyze your big data in an affordable and easy-to-use way. You can see the various advantages of cloud listed on your screen now. You can leverage all the advantages that the cloud offers, such as pay-per-use, high availability, elasticity, and so on, to solve your big data problems. However, you need to use your discretion to correctly identify whether your big data problem really needs cloud. Gaurav, why don't you go ahead and tell us what really qualifies for the cloud?
Sure, Lisa. On your screen, you can see some of the parameters that indicate when to bring the cloud. These are basically the indicators or the symptoms which give you an idea that when you can use cloud for your big data strategy. I would recommend using cloud for big data strategy when you realize that your data has started growing exponentially, or if you need a centralized location for analyzing your big data. You may also consider it moving your data from one place to other becomes difficult due to availability, geographical independence, or security constraints. The traditional approaches to scaling the storage and processing just have reached their computational and operational limits. These traditional approaches often depend on brittle clustering techniques and master slave deployment patterns. While yesterday's application may have been well served by these patterns, they fail to meet the needs of today's rapidly growing data sizes. In fact, any approach that depends on holding a collection of files, data elements, or metadata within the root, but few machines will eventually run out of space. The hierarchical model, which serves the organization or cluster, the controller machine can alleviate the pain, but they put a tremendous performance and reliability pressure on root nodes. Additionally, these models tend to require specialized hardware, high dollar per terabyte cost, making these large-scale deployments expensive. Today, the organizations are using unnatural design techniques and unsophisticated reporting tools to mine the insight from the available data sources. Unfortunately, the available architecture, tools, solutions are just too expensive, too slow, and too rigid to support their strategic business initiatives. But bringing the cloud into the picture, it offers a new analytics paradigm for both business and technology to gain competitive advantage from the big data. The cloud helps organizations to do away with the obsolete manner of retrospective reporting and deliver forward-looking predictive analytics to the masses. It facilitates improved business decisions at all levels of the organization. What may be the most interesting aspect of cloud is its capability to deliver actionable insights through ubiquitous and collaborative user experience. Cloud brings the on-demand processing power on the massive data set and digs out the actionable insight buried within the big data. It also enables the seamless integration of actionable insight within the user work environment and whatever that might be.
Thanks, Gaurav. That was really very helpful. We're now going to explore the advantages of big data and cloud partnership. Big data and cloud are really just made for each other, as you can see on your screen. Using cloud for big data analysis provides faster solutions and significant cost savings, which makes this alliance just perfect. This association increases the organization's ability to handle large customer bases and also provides deeper and faster analytics. The big data problem is not only about the size of the data, it's also about the performance and how fast the data can be processed. Let's see how these two disruptive technologies get integrated to solve business problems. The cloud and big data marriage has distinct advantages. This association ensures the agility to provision and reassign massive computing resources on demand as driven by the business priorities. It also provides the ability to analyze more granular and diverse low-latency data sets, or big data. Preserving these detailed nuances and relationships in the data yields the differentiated insights, which in turn enables optimized business performance. Additionally, this alliance facilitates the cross-organizational collaboration around the key business initiatives and rapid dissemination of best practices and organizational findings. This association also gives a cost advantage to leverage the commodity processing components and analyze the big data to address and exploit various business opportunities. So let's go ahead and see how cloud fares as a big data platform. There are numerous challenges of the large-scale storage and application environments. They span from factors such as scalability, capacity, and performance to the overall system cost and complexity. The cloud principles provide sound direction in addressing these challenges. With its on-demand processing power and the ability to exploit fine-grained data sets, low-latency data access, tight data warehouse, and analytics integration, the cloud is the ideal platform for analytics. Now, if properly understood and deployed, analytics on the cloud can solve tough business problems and really deliver actionable insights to the business. Let me go ahead and share a few more reasons on why including cloud in your big data strategy is such a great idea. The first reason, as you can see on your screen, is that cloud supports agility. The cloud enables agility through highly flexible, reconfigurable data warehousing and analytic architectures. The resources can be quickly reconfigured and redeployed to meet the ever-changing demands of the business. The cloud also encourages an agile data warehouse environment that is as flexible and responsive as the business it serves. Cloud exploits capabilities such as on-demand aggregation, index independence, on-the-fly key performance indicator creation, or KPI, and flexible ad hoc hierarchical structures. The second reason that the cloud provides on-demand computing the second reason is that the cloud provides on-demand computing power. It's very difficult to discern the types of queries and analytics that the business might want to perform. A competitor's pricing or promotional actions might require a fund analysis to understand the financial and business impact upon your company. The most interesting analytics involve extremely variable workloads that make it difficult to predict a priority. Another great reason to use the cloud is also that it's collaborative. The applications like Google Documents can exploit the power of the cloud to build a community with a built-in collaboration. Collaboration just becomes a natural part of the analysis and decision-making process. Small communities of like users can be quickly formed to share findings around specific subject areas. Additionally, the cloud provides flexible, innovative cost models. This is probably the most discussed benefit of the cloud. Cloud has the ability to pay for the computational power that you need and when you need it, just like your electricity bill. And this enables new operating models with dramatically lower costs. We will now see why big data and cloud have the makings of a faster, smarter, and better alliance. The definitive application of the cloud technology as a large-scale data storage, development, and processing system allows your enterprise to master big data. The agility of cloud computing has applications beyond the effective use of data. Since all the data is now maintained in a centralized system, we can help develop and implement a centralized security policy that allows precise and well-documented control over sensitive data. Additionally, the cloud provides an environment that enables prototyping, testing, and deploying new applications in a fraction of the time and cost vis-a-vis the traditional systems. These benefits continue to grow even when more data is added to the centralized data system. This new data can be analyzed in the same context of data stored earlier. This in particular is a very notable benefit to the enterprise. Combining the agility of virtualization, scalability of the grid, and the simplicity of Web 2.0, the cloud really brings you the building blocks for leveraging big data. This includes simplicity, as the scalable systems can handle the biggest data sets with ease. It essentially results in a massive reduction in the development time and complexity. Cloud also facilitates scalability, as using multiple computers allow the system capacity to increase simply by adding more machines without any exponential increase in cost. Plus, it provides agility, as the individual machines are programmatically controlled and usually virtualized. Their tasks can be quickly changed and based on the changing demands. So, how do you go about including the cloud in your big data strategy? This implementation strategy can be divided into 3 phases. The first step is about making an effective decision. This includes analyzing the pros and cons of choosing cloud as a platform for big data. The other very important aspect is to analyze the cost of the implementation. This involves analyzing the deployment, operational, and the relevant training costs. Now, once we are through and have identified cloud as a platform for our application, we need to plan for the migration. Migrating to cloud is a big decision, and therefore there should be a proper plan to mitigate the risks. We will be discussing these items in detail in our coming slides. For now, let's look at step 3, which involves identifying the tools needed for implementing the big data solution. Let's look at this strategy in a little more detail. One of the biggest decisions the architects have to make is how and where to run their data center applications. Fortunately, there are multiple choices that reduce the cost involved and increase the business agility. These include server virtualization, internal clouds, public clouds, and external private clouds, and many organizations are taking advantage of these options. Server virtualization is currently being used by most of the organizations to reduce costs vis-a-vis cloud computing, but this trend is fast changing. To take advantage of the new opportunities offered by the cloud computing, organizations need to understand the differences between server virtualization and various types of clouds. To explain this, I'll ask Gaurav to just talk about this a little further. Gaurav?
Thanks, Lisa, and hello everybody. I think the first thing that you need to do is to determine the characteristics and the processing requirements of your application, which includes performance, storage, security, and availability. You also need to figure out the amount of data to transfer and the service level agreements. Then we need to create a process to determine where the application should run. This process begins with application assessment and using packages such as Novel Platespin Reckon and VMware Capacity Planner, which can be used to profile a physical environment. They also help to determine which application to virtualize for optimal performance. Next, the processing requirement of the application should be compared with the security concern of running that a particular application in each execution environment. The mission-critical application with high availability and compliance or regulatory requirements are not good candidates for running on public clouds or any external private clouds. This is due to the issues around the resource control and geographical location of data. Applications that require high level of security should run on-premise environment. Server virtualization or internal clouds is acceptable. You may decide to opt for external private cloud if the cloud provider provides the degree of security that you require. However, the current trend is to use private cloud for highly secure applications. Moving to the cloud also depends on resource capacity available in data centers. If you think it is difficult to upgrade the hardware you need, then cloud is better option. Also, the applications that reach peak loads periodically and retract are good candidates for cloud, and since you need not to make significant investment in buying more hardware.
Thanks again, Gaurav. We're now going to move on and discuss the critical role cost plays in deciding the migration of your big data to the cloud. Naturally, the organizations would have to consider several types of costs, including the IT infrastructure, data center equipment and real estate, software licenses, system engineering and software changes, staff costs, etc. Now, most of these costs can be calculated with spreadsheets, and indeed, the cloud providers such as Amazon have created the same for cost comparisons. However, we recommend that you consider some factors before deciding to migrate. The first being the actual resources consumed by a system, which is determined by its load. The next is the deployment options used by a system, which can affect its costs. Some processes, such as data transfer, is more expensive between the clouds as compared to the data transfer within the cloud. And lastly, the process provided by the cloud vendors can change at a very short notice. There are also some cost modeling tools available in the market which cover some important parameters, such as the virtual machines, virtual storage, and the software applications that are deployed on these machines. Having discussed the cost model, let's go ahead now and compare the fixed costs versus the variable costs. The general consensus seems to be in favor of cloud computing. The cloud gives the ability to move the so-called fixed costs to variable or operational costs. A key economic driver for the use of remote capacity or cloud computing is in its ability to convert fixed costs into that of a variable cost or a cost which is volume related or pay per use. This seems to be the industry standard way to justify the use of cloud computing. Then there's the question of capital expenditures or CAPEX, which is the expenditures to create future benefits. For example, the money Amazon spends on building their web services infrastructure. One way to look at cloud computing is as a method of deferring CAPEX. This means that by utilizing someone else's infrastructure, you can choose to pay if and when you need any additional capacity as a variable cost. So potentially, the ability to create a hybrid cloud model that uses both the existing resources as well as the cloud may appeal to the organizations. The other motivating factor is the operational expenditure, or OPEX, which is an ongoing cost for running a product, business, or infrastructure. In the cloud world, OPEX is considered as a great unknown variable. It may be cheaper upfront to use a cloud provider, thus reducing your CAPEX. However, in the long run, it may cost you to manage your remote assets. At the end of the day, I believe that it is economical for most of the businesses to use the cloud. So the question is, how do we plan the migration of your big data to the cloud from traditional data centers? I'll ask Gaurav to elaborate.
Thanks, Lisa. I will share with the audience the Impetus failure-proof approach to migrate to cloud. You should start with identifying a problem that business leaders can understand and relate to, one that commands their attention. The next step is not to focus on the technical data management challenge. Remember that the resources need to be invested to understand uses for the data inside. We should also define the questions needed to meet the business objectives, and then focus on discovering the necessary data. Once this is done, it is essential to understand the tools available to merge the data and business processes so that the result of the data analysis is actionable. The migration of an application to cloud involves deploying the application on cloud servers. The first step in migration to cloud model is to determine whether the cloud-based server hardware and operating system are compatible with current server hardware and operating OS. If the hardware is not compatible, the application might need to be recompiled or redeployed for a new platform. Similarly, if the OS is incompatible, few changes will be required when the application is migrated. I believe that the SLA or service level agreement are essential for availability and performance of server, network, and storage infrastructure to minimize the risk involved in migrating to the cloud. You should also inquire about the maintenance and management procedures for the infrastructure and figure out how any potential downtime is handled. Furthermore, in a cloud deployment, the application might be using a database server that is also deployed on the cloud. In such a scenario, the cloud service provider must provide a way to replicate or migrate the block of file storage that is used by the database servers. Other factor that you should consider is long-term cost. The cost of cloud application should be compared against the cost of deploying the application on enterprise servers. In some cases, a public cloud deployment might have an obvious benefit because of dynamic scaling and usage-based pricing. However, for the always-on application, the cost of ownership in a public cloud might actually be greater than using in a private cloud. User management plays a big part in determining the migration to the cloud. In a cloud, there might be up to 3 different roles, including server administrator, or application user. The user management procedure and tools for each of these roles should be evaluated. Lastly and most important is security, which is a critical aspect. In a cloud deployment, the virtual machine belonging to different customers may be implemented on the shared physical infrastructure. While considering the application migration, the service provider security policies for virtual and physical isolation as well as the compliance should be examined. The cloud service provider should allow the auditing of these policies using emerging technologies and specifications such as those of cloud audit. And of course, the applications that are designed to scale out will benefit immensely from the dynamic scaling feature of cloud. We will now discuss the best possible approach to selecting the right tool to address your big data problems. You need storage systems which are required for storing big data. The primary features are being non-relational, distributed, open source, and horizontally scalable. Very often, some other characteristics may apply, such as schema-free, easy replication support, simple API, eventually consistent, huge data amount, and more. These are termed as NoSQL databases. They can be classified into various categories, like column family-based data stores, which are like H-based Cassandra, document-based data store like CouchDB, MongoDB, and key-value-based data store Membase and Redis. Column family-based databases are best suited when you write more than you read, and also they are good when you are designing an application in Java. The document-based data stores are most appropriate when you need dynamic queries, as well as when you prefer defined indexes and are not using map reduce functions. Lastly, the key value-based data stores are best suited for rapidly changing data with a foreseeable database size. For example, using in stock prices, analytics, real-time data collection, and real-time communication. There are various tools available in market like Scoop, Keho, which may be used to import the data from traditional databases to NoSQL databases. Using these tools makes sense when you are re-architecting your application for big data architecture. We will now talk about which analytics tools to use for your big data. MapReduce is a programming paradigm used for performing analysis on large volumes of data. We can use Hadoop for large-scale computation and data processing on a network of commodity hardware. Pig and Hive can be used to remove the complications with Hadoop and to give the programmers an easy interface with Hadoop. There are many options available in the market that allow integration of massively parallel processing data warehouses such as Greenplum, Astrodata, etc. with Hadoop. This is worth considering if you have a large volume of data even after applying summarization of it. Using Hadoop for cleaning and transforming the data into structured form allows you to load data into any available options of MPP data warehouse. While the data is being uploaded, you may write your function like UDF to perform database level analytics. So how do we implement the chosen solution? As the data warehouse grows to terabytes and beyond, the conventional relational database management system often proves inadequate. There is a need to perform the cleansing operation to obtain the sensible data, and finally, mechanism to draw conclusion over this data. What's important at this point is that we need to bring down the time required to do the analytics and derive results in form of conclusions. And for all these, we need to be aware of right tools that we can choose.
Great, thank you, Gaurav. That was very informative. We're now going to see a real-world example of harnessing the power of cloud to address a big data problem. Recently, we at Impetus engaged ourselves with a client who is the leader in the Internet and multimedia services in Europe. Our engagement with the client started with understanding their system and to develop a new reporting system for their leading web portal. There were some basic concerns that the clients wanted to address, such as performance, horizontal and vertical scalability, handling large volumes of data, and providing near real-time analysis on the subset of data. Our client was also looking for the scheduled reports, both daily and weekly, of complete data sets, cloud compatibility, and periodic data consolidation and filtering. What made this project all the more interesting was that the web data traffic on the portal was immense. The number of page views had crossed a whopping 3 billion, and the number of user logins to 70 million per month. They were also expecting a growth of 300 gigabytes in the data set. So, based on a thorough analysis of the client requirements, we proposed a solution that was cloud compatible and was able to handle the client's big data needs. Our solution comprised some popular open source technologies like Flume, HBase, Hive, along with our custom analytics platform. In the system, the logs were collected using Flume. Now, this data was stored in an unstructured format into HDFS using HBase or directly over HDFS. For the analytics part, the data model was presented in the form of Hive schema. The application also had a component whose main responsibility was to initiate or trigger data aggregation process over the raw fact data to the aggregated or archived data. The next step was to create reports over this collected data. The first component that we built was mainly responsible for generating weekly or monthly reports. This component was interacting with the data storage system via the JDBC bridge, for example, Hive JDBC bridge, to extract the required data for reporting and analytics. The component was also responsible to produce reports in the desired format like PDF, CSV, etc. Now, once this was done, we built a component for near real-time reporting. Since this report is to be generated over a limited data set, it was easily achieved via Hive-based analytics. This solution was able to generate results in less than 15 minutes, which was quite acceptable to our clients. The complete solution was based on the Impetus large data analytics platform, LDAP, and was deployed on the cloud. Since the application we developed was virtualized, it didn't take much effort in porting from one cloud provider to the other. All the components that we used were ready-to-use components of the Impetus LDAP platform, and therefore provided a POC-free implementation of the solution. There was minimum effort needed for installation and setup.